Hello and welcome to Maths 7. Okay, so what I'm going to do this time is I'm just going to look in general all about kind of equations, how we might get to them. So the things we're dealing obviously with numbers, we're dealing with sets, and we're dealing with functions. Okay, so they're what we're going to be doing in terms of like algebra. So they're the sort of the objects that we deal with. But what kind of but to get the interrelationship between these objects, obviously there needs to be kind of manipulations that will go on in order to get these objects to operate in a in a meaningful way. So we have to consider certain things. We have to consider operations on the objects. We also have to consider a composition of functions. Okay, and also the union and intersection of sets. And there's sort of some of the operation, some of the things that we're going to be doing when we deal with numbers, sets, and functions. Now, obviously, in algebra, we deal with x and y and all this stuff, and we can call these dummy variables. So they're simply a means to an end, these variables. So for instance, if we had, say, 5x plus 8, then the dummy variable there would be x. And keep in mind that this notion of the dummy variable means that it's a universal definition. So if we had, say, 5 and then we had a box plus 8, if we set this to be, for instance, say we set this to be equal to 10 and we set this to be equal to 10, it's not going to make any difference what the name of the variable is. It's always going to be the same answer. So there's a universal definition, and that's because of the dummy variables. So in general, we're looking at the most important thing for maths really is to be organized, for one, to use standard notation, and also and complete sentences. So that way there could be, for instance, like what I did there. There's no need for there to be any kind of doubt. Well, there shouldn't be any if it's done properly, as to what is being expressed in whether it may be the equation or an inequality, perhaps. So let's just go through all the symbols very briefly. So we've got addition, we've got subtraction, negation. So obviously subtraction is always going to be more subtraction, I mean, it's more to, there's a lot more to subtraction than there is to addition, because obviously you can add up two numbers either way, but if you try and subtract two numbers either way, you're going to run into a bit of trouble. So Then we've got multiplication. Okay. Got division. Okay. And then have the radical, the root. So yeah, and I should do that as well. Okay. Of course, there's more elements of notation. So next up, we can put there's certain groupings. So we've got those. Got the square brackets as well. And finally, the curly braces. So they are ways to group together various, it could be numbers or it could be variables into a coherent way. Also, if we're dealing with inequalities, we might have greater than, and less than. So that's another thing that we might be dealing with, just dealing with an inequality. Yeah. So in general, again, I'm going to do a general. We talk about terms. Things which are added. So, let's talk about adding like terms. Factors. Things which are multiplied. So this is always a problem to know in algebra, to know when to add, when to subtract, and when to do multiplication and division. Because obviously, if you don't do them in the correct order, things go wrong. Yeah. And of course, the classic sign, the equal sign. There it is. And that can be equivalent to as well. You can also do, let's try to, that's approximately equal to. So yeah, so we could say, for instance, that the root of 2 is approximately equal to 1.41. Okay, so yeah. Now, the most important thing though is when is to create. If we're talking about sentences, we say we're going to create paragraphs. You need to be able to follow one thing by another, and there's two types of way that a sentence of mathematics can proceed sequentially onto the next sentence. And there's ways of, it's kind of a mini verification. So if we have this arrow, this is an implication. It implies implication. And it could be seen as the same as if ... then. And the other kind, I'll just I was thinking of putting a line between them, but the line may go a little awry, so I won't. And the next one is the double implication. So we can go either way. And this is the same as if and only if. Or it could also be thought of as IFF. Is equivalent to. So one statement is equivalent. If we see this notation, it's going to be equivalent to. So it's more specific, and there's more there's different ways you can go. It doesn't matter which way you go. Kind of a bit like the absolute value we spoke about in the last episode. Okay, so we just look at a few conventions now. Okay. So in general, the early letters of the alphabet are for constants. Okay, so this is a constant which is not going to be changed, which is already known. We look at the middle letters of the alphabet. These are integers. So, for instance, if we were doing a summation from 1 to 10, we might set I to be equal to 1 at the start, perhaps. The letters at the end of the alphabet. Make sure I get I like to do the X with it's like a backward C and then a forward C. I've always done it that way. And these are the variables. These are things which we don't actually know. And often they're the whole point of doing the maths. Find out what these things are, these variables. Okay. So if we go back into look at maybe the structure again, we can perhaps draw some parallels with regular talking, with spoken word. So we could perhaps say, well, we've got nouns, and we can call them number expressions, or expressions which reduce to simply to a number. So it could be 5 squared, perhaps, or 3 lots of 5 minus 2, or anything really. The point is that they resolve to a number. So it's merely a case of doing some fairly simple arithmetic to simply work those out. So they could be seen as the nouns. Yeah. So then we could have pronouns. Now pronouns, of course, describe the noun in English. So these are going to be variable expressions because they're describing what's going on, but they're not actually explicitly stating it. So if we so we could do say 3x 5b ac y squared. So they're not actually saying, they're variable, they're describing what's going on, but they're not explicitly stating it. Yeah, I mean, they're basically just describing, it's an aspect of the noun, isn't it? It's one way to portray the noun. And of course there are infinite ways to do so. So then we have the main verb. And this is going to be what we go into algebra and equations. which is obviously looks kind of coming up. There's obviously the equal sign. So an equation is a declarative sentence. Declarative didn't turn out too well. Oh well. There's a declarative sentence in which the verb is equals. Okay. So yeah. Now, from a sort of top-down perspective, one of the things that we have to consider is how let's do facts. So obviously, for instance, when actually talking, it's the case that often some of the words which are spoken are derived from the fact that they were facts already. So so one way of looking at that is to look at the kind of main tenets of maths. And what we have is we have theorems, we have corollaries. Corollaries didn't really. It'd be nice if it was an easy word to say, but I guess I will have to learn how to say it at some point. And then lemmas. So if we imagine the fact importance, for instance, in general, we could say it's like we could do fact significance. So if we have like fact significance, So as we go, for this way to this way, it's becoming less important. And as we go from this way to this way, it's becoming more important. So that's one way to look at it. So theorems are the most important, corollaries less so, and lemmas less so. But they're all statements of fact. All the facts. So just put that in there as well, why not? Okay, all facts. Yeah. Okay. So let's do implication one more time. We obviously just spoke about it a moment ago. Let's just do an example here. So the example we can say, if A and B are odd natural numbers, okay, and this is kind of getting into okay, so if A and B are odd natural numbers, then A plus B is even, rather. Okay, so what we're dealing with here is one way. So if we consider the how can I put this? So say we've got 17 and 19, 11 and 15. Okay, so we get 36 and 26. So if we do some examples, we can see so it's pretty obvious that is the case, though, right? So it's always going to be the case. So we could say that is true. But then if we look at this, A plus B is even. If we had two even numbers, if we had 4 and 6, then the result is going to be even as well. Which means that... Okay, so yeah, like I was saying here, so if A and B are odd, then odd natural numbers, then A and B is going to be even. So this is like yeah, I probably could have put this down here actually. Then A plus B is even. So I'm just going to get rid of right there, and then we can say this is a one-way implication, because obviously because we could a plus b could be even if two numbers were even themselves, if a and b were even. So yeah, that's a one-way implication. So that's one-way implication. Now, the other way to look at it is if we have x plus a. Well, mine's getting a bit wavy now. If x plus a equals b, then say we subtracted a from both sides. So we subtract a from both sides. Then we're going to have x here, and that's going to be b minus a. So what we can say here is that this is a two-way implication. Two-way implication. And that's because we can get from one to the other. So for instance, if we wanted to go back, we could plus a, we're going to go back. So it doesn't matter which one you start from, similar to what I spoke about with the absolute value stuff, you're still going to get the same result. So it's a two-way implication. So you wouldn't really be moving on in the sequence here. You would be simply making it's like reducibility, whereas one-way implication is moving on in the sequence. I guess is one way to do it. But there's only two types. That's the key thing. Only two types of fact. Two types of fact. And that is going to be the end of Math 7. So until